What we're doing here is looking at LeChatHeat's principle, but we're looking at what changing the temperature would do. Now, changing the temperature is going to be essentially the exact same as adding or removing a product or reactant. So what's going to be important is what side of the reaction the energy is on, what side of the reaction the heat or the kilojoules is on. In this case, it's an exothermic reaction, and I know that because the word heat or the numerical amount of kilojoules is on the right-hand side. So it's a product. So that means that as the forward reaction goes, heat is going to be released, which means exactly the opposite is going to be true as well. When the reverse reaction goes, heat is going to be consumed. So now, let's look at what happens when I increase the temperature. Well, I always have to think of what's the opposite, right? What's the opposite of increasing the temperature? Well, it's decreasing the temperature. And in order to decrease the temperature, we're going to need to use up the heat, not make more heat, but use up the heat, which means the equilibrium is going to shift to the left. And the components on the left, the CO and the H2, are going to go up. And the other guys that are going to be used up in the reverse reaction, the CH4 and the H2O, are going to go down. And the exact opposite is going to be true when we decrease the temperature. So what's the opposite of decreasing the temperature? Right? The opposite of that is going to be increasing the temperature. It's going to be making more heat. So it's the right-facing reaction that is going to speed up, which means that these guys, reactants in that right-facing reaction, are going to go down, and our CH4 and our H2O are going to go up.